Paris for that. Thank you for the introduction. Again, my name is Alice Harriet Mangora-Temo, and I am a lecturer in the Computer Science Department, Leicester University. Yeah, and welcome. I extend my welcome to all the audience this evening. And what I'm going to present basically is how we can be able to integrate or the process or the journey of Africa or sub-Saharan Africa trying to integrate emerging technologies in agriculture to achieve a thriving bioeconomy. And what I'm doing here is just basically, I don't know what's the background of the audience, but just to try and walk us through the need of adopting these technologies, especially the why and the need, so that you can be able to meet the African need in terms of food security. So basically, that's what I'll be taking some time to take us through this evening. So I've done this work with, this is Professor Josan Dege from United States International University, and that is a collaborator that I am working with in this work. So as you've been told, my specialties are more in information security and looking at emerging technologies. And now I'm trying to fix this or find a path in how they connect in the agricultural field.
Yes, excuse me, Harry. Can you put it in presentation mode?
Let me do, yeah, that's what I want to do. Okay. So basically, when we try to look at the world population and the trends at which growth in terms of population is taking place, looking at the first figure at this particular point, we see that actually sub-Saharan Africa is growing in terms of population at a very high rate. And the projections by the year 2100 are going to be towards 5 billion in terms of, and I don't know how, this is a projection that is given by the China Center for Disease Control in 2021. And that's what they were projecting in terms of sub-Saharan Africa in 2100. Those are about maybe 70 what? About 76 years from now. But just coming a little bit nearer where we are, looking at the projections of 2050. 2050, you can see we are looking at, currently we stand at about 1.2 billion in Africa, and the projections basically will stand at 2050 at around slightly above 2 billion. So you can see in terms of the population, we are actually growing. But when we look at statistics that are being given by, put this down, hide the thumbnail. The statistics that are being given by FAO and basically in collaboration with the International Fund for Agricultural Development, UNICEF, World Food Population, World Food Program, and the World Health Organization. Basically, the key message that is being passed as at 2023, that is last year around December, is that Africa is not on track to meet the food security and nutrition targets according to the SDG number 2, that in terms of trying to eradicate hunger and ensuring food security. And according to the Malabo targets of ending hunger, basically, and all forms of malnutrition by 2025, what is being said is that Africa is not on track. So in as much as this has been said, what we see that is that between the year 2000 and 2010, we had made some quite some progress in terms of how we were moving towards meeting this particular target. But after 2010 and the years that followed after that, actually what was observed that hunger had worsened substantially. And now come in 2019, when we were being hit by COVID to 2022, we had the worst deterioration, meaning that we had over 282 million people undernourished and 868 million people food insecure, okay? So in terms of Africa by sub-region, what we see that in East Africa itself, you can look at the trend at that particular point. I hope my slides are moving. Perez?
Yes, yeah, they are moving them.
Okay, thank you so much. Yeah, so what we see that looking at Africa, because now we're interested, our research is more interested to find solutions for Africa as a continent. We see that the trend in terms of food insecure people has only continued to increase. That is again in line with the projection that has been given by FAO. And in terms of those that are undernourished, we are competing with Central Africa in this particular statistics, but we are still, at the edge, and we are still among the leading in terms of the continent, and even as sub-region, East Africa, we are not actually doing very, very well. When we look at numbers, in terms of East Africa, we can see that by the year 2022, we were looking at 27.7% of the population in East Africa still suffering with food insecurity. When we come closer home to try to look at the numbers again, when we look at Kenya, where I'm speaking from, we are looking at 28% of the population being subjected to food insecurity. We can see Somalia is basically, not Somalia, but South Sudan is not doing very well. We are happy at least Sudan, though the population is small. Sorry for that write-up. We have Ethiopia there. Uganda is trying at 24, but we can still see that actually the trend is that we are moving, but we are not moving at a very good pace. So in terms of the SDG 2, to end hunger, achieve food security, and improve nutrition and promote sustainable agriculture, what we are seeing from statistics, as I've mentioned, is that more than 600 million people worldwide basically are projected to face hunger by the year 2030. That is just 6 years from now if things do not change, all right? So then when we started looking at these studies, our idea was to try to understand what strides is Africa making in terms of trying to adapt the technologies, all right, or rather to adopt the technologies that are here so that we can be able to meet this food, the food gap in terms of Africa. So the aim was basically to try and use these particular technologies to eradicate hunger by 2030. That is quite near. Progress is very, very slow. Okay, as we basically are going to look at the statistics and look at the reasons why and what are the opportunities that this is presenting for us as researchers, both, as private researchers in academia, to try and meet this particular target, okay? So we know one of the reasons that we find out now from literature or from, publications is that this slow progress is being attributed to one, there's lack of data. Yesterday I was at a Microsoft conference and we're talking about AI, and one of the something that was coming out very clear is that we need to provide solutions that are using African data, our local data. So we could have solutions that are outside there, but that data does not resonate with the African continent, with the Uganda people, with the Kenyan people. And then we also might not be moving very fast in terms of adopting the data-driven strategies. That's according to the UN Assembly, again, 2023, and Okello et al. 2021. So according to the Global Bioeconomy Summit, again, the term smart sustainable bioeconomy has been defined as a center of production, utilization, conservation, and transformation of the biological resources that we have as a continent. But how are we doing this? Through the use of digital technologies. What is the objective? To provide real-time and continuous data and information that will contribute to improving the circularity, that is under the circular economy, and efficiency in terms of waste, water, energy, agriculture. That's why I'm highlighting that, because I have interest in agriculture, health, education, mobility, telecommunication, governance, and etc. But in this case, we want to look at these digital technologies and how they can be able to be, adopted in the agricultural sector. And then we see, yes, it does not mean that they are not there, but how much have we, picked up these technologies and run with them? So what basically, again, comes out under FOA is that these promising technologies are not gaining traction, especially in the LM ICs, that is the low and middle income countries where we fall in. And what is the reason behind this? One, they are saying that we are not contextually ready, to be able, to take up these particular technologies. In terms of context, is our context ready? Are the people ready? Are they, the governments, are they ready to be able to do what? To take up these technologies? There's also a lack of appropriate enabling environment. So the environment, the champions, for this technology so that they can be, taken up is also something that is not lacking 100%, but there's some lack in terms of the support. Then the diffusion and adoption. At what rate are these technologies moving within the African continent in terms of adoption? Those are some of the challenges that are coming in. So basically, in summary, I would say that hunger remains a major issue in sub-Saharan Africa. All right. So while we know that those traditional ways that are being used to try and provide solutions, but they may not be sufficient to provide, as when you look at the rate at which the population is growing, and that's why I started by showing you the numbers and the figures or the projections. Basically, if we keep using these traditional solutions, we might not be able to meet the food gap in terms of Africa as a continent. And as you were saying, by 2030, we are looking at 670 million and above. Actually, when I was looking at these numbers sometime this week, they were hitting above 700 million. Okay. So now we look at agriculture 4.0 technologies. These emerging technologies basically have to do with the way we are leveraging the 4G network. So that's why we get the term, a smart agriculture. We are talking about precision agriculture. We are talking about agriculture 4.0. We are actually looking and staring at the adoption of agriculture 5.0. That was the technologies that are going to leverage the 5G network. But again, the question is, as you're going to see as some of the challenges, what is the connectivity rate? How many people in the African continent actually can be able to tap or can be able to access in terms of coverage the 4G network? Okay, so basically when we talk about agriculture 4.0, which is in my title today, is basically looking at the use or leveraging emerging technologies. We look at this, what are these emerging technologies to achieve long-term development in agricultural context. In terms of, for example, crop production, can we be able to project the soil monitoring, animal production and management and monitoring, etc. So that's why we are going to leverage these particular technologies. And they could bring about major global improvements, not only for Africa as a continent, but even beyond, according to research done by these guys, Abasi et al., in terms of increasing productivity and efficiency, looking at the quantity, and now we are even concerned with the quality of food that is being produced, and even the accessibility in terms of even distribution. Are we able to distribute this food so that areas that are marginalized, areas that maybe are a challenge, are also able to access these agricultural products? Then they can also be leveraged in terms of using them to adapt to climate change, reducing food loss and waste, which I mean is quite a lot, where we have too much. Most of it will go into waste. For example, you could have a region where they're growing too many tomatoes that are seasonal. They're not able to absorb that. But there's another section of even Africa, or even within, for example, a country like Kenya, where they're not able to access tomatoes. So we end up with a lot of loss and a lot of wastage. Then how can we optimize and leverage, again, these agriculture 4.0 technologies to optimize the use of the natural resources, which are limited, all right? How can we be able to optimize those particular limited resources so that we can be able to get, maximum output out of them, and then reduce the environmental impact? So those are some of the improvements that we could have if we adapted these particular technologies. So what methodology did we use to be able to basically arrive at the conclusions that I would be making, and what are the research gaps that we could leverage on to try to meet these particular gaps? So what we did is we tried to look at a 10-year period by trying to carry out a systematic literature review to look at the publications that have been done. As I would say, yes, there could be work, but the other challenge is, where is this work? Is it visible, so that we avoid replication or maybe just, redoing what has already been done? So we looked at papers basically from the year 2012. We're targeting 2012 to 2022. And of course, between 2012, 2013, we were not finding too much literature. 2014, as we can see in the graph provided, 2015, 16, 17, we could not pick papers based on the databases that we're using because we looked at 3 databases. That is Science Direct, where there's scholarly, work being put there. We had looked at Google Scholar as a secondary database, and we looked at IEEE as a secondary database. All right. And we realized that most of the publications we were looking at were between the year from 2019, 2020, and majority from 2021, 2022, which would give us a strong ground to argue that this is what we have outside here, and there is some work that is being done. The other question would ask, who is doing this work? Is it the Africans doing it, or it is, the other people that are doing it? So we could apply these emerging technologies in 4 main areas. There could be more, but I'm saying 4 main areas in terms of domain. In terms of monitoring, where we would look at, for example, you want to monitor the weather, you want to look at I'm looking at this, I'm remembering this word that I was using, the greenhouse gases, that is the GHG monitoring. How much emissions are being done from the greenhouses? How do you monitor crop growth, soil monitoring in terms of the nutrients and the components, animal monitoring, etc. We could also use it in terms of control. How much water are we using to irrigate? How much fertilizer are we injecting to our soil? How much pests, weeds and pests and disease we can be able to control in terms of what there is within the plants and the animals. Smart greenhouses, harvesting systems. We can also use for predictions. How, especially now we are talking about climate change and the effects that it's having, and more the world at large, but we would have interest or lean towards Africa as a continent. We want to look at how being able to predict. You can see nowadays the weather guys will tell us, it's going to rain, but it's not raining. Or they tell us it's not going to rain, and suddenly we have heavy rains that we are not able to know what to do with them. How can we be able to predict, how much product are we going to get from my half an acre, my 1 acre, my 10 acres, etc., and crop, animal development, and even the market demand? Can we predict how the markets, statistics are looking at, so that we know this area, basically this is what they can be able to consume, and if there's an excess, we can redistribute it to a different area. We could also look at it in terms of logistics. How do we handle, food and how it is stored so that we do avoid, wastages? How do we transport and redistribute this particular food? Look at the supply chain management and even traceability of basically what has been moving around. So what we were able to find out is that we were able to pick at least 14 main emerging technologies that would find, usage in agriculture. And among the first 8, that is in terms of the Internet of Things, the wireless sensor networks, cloud computing, big data and analytics, machine learning, deep learning, decision support system, and artificial intelligence, we were able to find that they were finding some footing in the African continent. All right. But in the publications, because we looked at about 55, analyzed about 55 papers, we realized that when we look at emerging technologies like edge computing, autonomous robotic systems, cyber physical systems, digital twin, blockchain, augmented reality, and virtual reality are technologies that have not found footing in Africa, or at least not within the publications that we were able to look at. The other thing we looked at as what are the determinants that would drive the adoption of these agriculture 4.0 technologies. And we looked at it, we looked at the publications to see whether, literature or scholarly writing is giving us what are they doing in terms of providing the theoretical frameworks that basically would help us understand the drivers or the determinants behind, the adoption of these agricultural technologies. So we picked the technological, the organizational, and environmental factors. That is basically TOE that was coming out as a framework. In a lot of the publications, they were really not talking about any frameworks that they were using, which again creates a very good, fertile ground or an open gap that you can be able to now leverage on what are these, information system theoretical models that we can be able to adopt that can help us understand the reasons why we are not leapfrogging and taking advantage of these particular technologies. So we looked at the technological factors. Maybe we have the off-the-shelf solutions that we may not be able to clearly understand, or they're not easy to understand, those kinds of things. There are issues around security and privacy. If we're having all this data outside here, how sure are we that this data is secure and it's kept private? There are issues to do with knowledge management. How do we implement systems or solutions that are dynamic and adaptive to different environments? And then issues of integration and interoperability. Okay, do we have, what kind of APIs do we have? Are we able to connect to these particular technologies on the go or on the fly? There are also environmental factors in terms of regulation and policy. This morning, I was looking at the AI. I was listening to actually another webinar on AI policy. And, until yesterday, again, we were having this community of people coming together and realizing, we have AI in place. Do we have the policies? Do we have the regulations? How we are dealing with the challenges that are coming in? And there's a lot of talk about, there's a lot of talk around this. So this, among the environmental, as an environmental factor, is one of the determinants. Do we have standardizations, which again comes to, governments? Do we have either governments putting in place or private entities, or the private sector coming up and helping provide standardization? This morning we were talking about with the Kenya Bureau of Standards, and they were giving us, the different types of standardizations that exist, and how do we plug in when we are coming in with these new technologies so that we are able to work coherently. There are issues to do with infrastructure. Do we have the infrastructure? Do we have communication, networks that are there? As I said, for example, in Kenya, we would say, yes, we have coverage. But there are sections where you go and find, we have zero coverage. Or where some people, for example, in Nairobi are accessing 4G network, we go to the rural areas, accessing even 2G, 3G network is still a problem. So that disadvantages the people in the rural, for example, communities who would form a bigger, proportion of the farmers that would contribute to the food basket. Then we have the legal and contractual assurances. What is the legal, fraternity saying about these particular technologies, so that tomorrow you're not using something in a way that the legal fraternity will come and say, this is not the way you should have used it. When we come to organizational factors, we talk about what is the digital strategy of a country, all right, or of even East Africa, or of Africa as a continent. Are we able to understand the benefits that come from leveraging these particular technologies? What is the cost implication? Most of them actually could be very costly, let me say so. For a farmer who is having maybe half an acre or even a quarter an acre to try to leverage these particular technologies. And then in terms of modifications, can we be able to customize them in a way that they can suit, our very diverse and dynamic requirements? And then there's the issue of skills gap. Do we have the right skill gap to be able, we have these people, this group of people or trained people that can be able to understand the workings of these particular technologies. In as much as I'm listing all these 14 technologies, I wouldn't say that I stand at a position that I can be able to equally, very well and clearly explain. I have an idea of what they are all about, but do I have the right skill? I could have skills in one or two of them or three, but not all the 14. Then is there collaboration within the research and development, community again? And then organizational, this in terms of organizational resistance. Recently, I was also looking at the biases in AI, and I realized there's also the individual resistances that come in. Are we resisting as individuals to accept that, AI, for example, is here and we're not running away from it? We need actually to embrace it. So those are some of the, the determinants that we looked at in terms of TOE in our research. And we also tried to look at the challenges of agriculture 4.0 technologies when we try to minimize them and bring them to the African continent. Those would be, would apply even outside the continent, the ones I've talked about. But when we're coming down here, we want to see again, what is it that resonates with us as a continent or as East Africa? I want to assume many people from here are from East Africa. So there's the issue of scaling. As I said, again, a lot of the rural farmers will actually intercrop. You're planting beans, you're planting maize, you're planting some groundnuts within the same ground at the same time. How then will these allow you to carry out efficient, for example, monitoring? Because these plants will have different requirements and different needs at different times. All right. The issue of financing, as I've said again, in terms of East Africa and Africa, financing is still a big challenge. And then leapfrogging tech opportunities. These technological, what do I say? These technologies basically have taken some time in the developed world to reach where they are. We cannot afford as Africa to start, from the scratch, to understand, try to, follow the path that, developed countries have used. We must look at ways to leapfrog. That means we must jump ahead, understand them very fast, and then take or leverage the advantages that these technologies have. There's digital infrastructure availability, which is still a problem. Again, institutional issues, governance and ethics, still problematic in East Africa and Africa. And then the lack of skills, which is a very big gap, again, that we are having when I try to compare this with Africa. Now, if I go down now to look at the specific, challenges for the different technologies that have found footing in Africa, and to see what is it we can do, because for me, that is what is critical. What is it we can be able to do to tailor these technologies so that they can meet the African need? So looking at the Internet of Things, what are the writers basically saying here? And again, I need to note that most of these writers, I would say they are not African writers. So meaning they could be either, other people from outside the continent who are doing research in Africa. And as at yesterday, again, we were saying the conversation was how about Africans doing the thing for Africa. So when we look at IoTs, we are faced with the challenge of limited connectivity in terms of Africa and the power grid infrastructure. So that means most of these technologies or applications cannot be optimized or even used, leave alone optimization. They cannot be used in remote areas where we don't have connectivity and we have unreliable power grids. The power is not reliable. It is here and it is not here, okay? So that creates a challenge. Maybe now it will be about talking to our governments and ensuring that, there's 100% coverage, which is among the digital strategy. For example, I would say for Kenya, they are trying to beat that particular, that race to ensure that we have that 100% coverage, but it may not apply to every African country. When we talk about the wireless sensor network, we realize that wireless sensor networks are resource constrained, basically devices, all right? So then we need to think of how researchers can come up with what we refer to as energy efficient algorithms. Algorithms can be heavy, and especially in terms of their deployment, and that means you require the space and the memory. So you require the machinery, and you require a lot of memory in terms of resources to run these algorithms. So we need to think as a continent then on how we create algorithms or develop algorithms that are lightweight, all right, that can be used. Again, one question that came out yesterday in our conversation is, even when we are talking about AI and the large language models, they are quite heavy. Can we come with lightweight large language models? I don't know then how large would come in again, so that you can be able to even run them, on resource constrained devices like mobile phones, all right, and power management strategies that basically would minimize the power consumption for the IoT devices, basically, that are used, with precision agriculture. Then there is also the concept of digital twins, which is quite new. So this is something that actually we may want to leapfrog by first understanding, because it's actually at prototyping level. So that means at conceptual stages. So we don't have actually proper use cases of the deployment of digital twins. But again, we might leapfrog by moving beyond, rushing and running or jumping to move beyond prototyping, all right? and come to a ground or a space where we're talking about practical, scalable, and impactful developments. So that remains, again, an open area of research. So an interesting one that is actually becoming a buzzword in the research community and even around us is that of artificial intelligence. So, sorry, that of artificial intelligence. What comes out very clearly is that we still don't have the skilled staff that can be able to meet the need for Africa. So there's room, for having to try to develop the manpower and the skill set that is required. There's also the big issue around privacy and security, because we will talk about these models, for example, being black boxes. Rather, they're opaque. And because of that, there are people who would be reluctant. We talked about that resistance to try to adapt these technologies because there are issues around privacy and security. For example, when you're dealing with sensitive data, okay, how do we ensure that even as we carry out the trainings, we are not exposing? There are issues now, again, that are coming in within the GDPR, the General Data Protection Regulations. Are there countries that are not, they're not compliant, okay? And therefore, there is that resistance as an organization to want to do business with them and leverage AI. There are also AI biases. We were able to come up with different types of biases, basically, that were coming out in trying to adopt these particular technologies. We're talking about the gender biases, we are talking about the contextual biases, we are talking about transfer context, that's related again to contextual biases. We are talking about algorithmic biases, which is very large, because a lot of these models, again, are trained on data that does not come from Africa. So when they make decisions, they will always make biased decisions. Okay, how about those people who are not, the disadvantaged or the rural women that will not be able to leverage these particular technologies? Would it create some inequality in terms of gender? Okay, and then the content moderation. Do we have sufficient regulatory frameworks? I would say as Kenya, we are trying to come out with, the AI, robotics, frameworks and policies. We're looking at the AI policies now coming in with, the standardization organization. They're now running to try to embrace this and realize that we have AI with us and we need to run fast and see how we can be able to work with it in an, for example, ethical manner. So we want to look at the regulatory frameworks as some of the research opportunities that are coming in. Can we develop unbiased data sets? So we need to understand what are these biases that could exist that are also contextual, right? Because someone would say, issues of, again, culture, how do they come in? What you may think is cultural in one set of people may not apply to another set of people, or what Ugandans may think, is culture to them, Kenyans may not think that is culture to them, and all these things need to be integrated. All right. How do we ensure that there is equity in terms of how this technology AI is being leveraged? All right. And then how do you bridge the gap between the farmers and the AI researchers? That also is coming out big again as late as last evening, when we were trying to say that when we are developing these AI models, means we need to engage. Let the farmer be engaged from the word go. Let us not develop a solution and take it to them. There could be resistance. They did not participate in its development. Their data may not have been captured correctly, so it is not for them. So we realize that there's that huge gap that needs to be bridged. And therefore, as researchers are proposing solutions and developers developing these solutions, then the farmer, because now in this particular context, we're looking at the farmer, they need to be engaged from the word go. Then we have deep learning, basically, that is also another technology. Here now, they were using the use of, the deep neural networks architectures. And the other question is how deep is this neural network, all right? What are the numbers of parameters that are being used? They could be trained, on millions or even trillions of parameters. And the complexity of the algorithms that are basically used to run these neural networks. So the question is that, how can we be able to remove this black box and make it a white box? so that now we have a better understanding, of course, as we develop the skill set of these neural network architectures, so that we can be able to leverage them for agricultural data. Then we have the decision support systems. This basically the biggest challenge is in terms of looking at the graphical user interfaces. How can they be made simple enough for that farmer to understand in that resource constrained device so that they can be able to support the agricultural life cycle? The other thing is that can they be able to adapt to uncertainty and dynamic factors as one of the challenge that is coming in? Okay, so want to look at how we, as researchers, or the developer community can look at whether we're talking about the UI, UX designers, come up with, better, easier to navigate interfaces and more richer functionalities that are adapting to dynamic needs of the farmers, also taking issues or into consideration the uncertainties and the dynamic factors that come into play when we're using the decision support systems. Now, when we look at the distribution in terms of Africa, because my interest is trying to see how are we doing as the African continent, is to look at where are we falling in terms of these, leave alone the technologies that are still at, don't find use cases in Africa. So we need to take advantage of them, but also need to understand them. But how about those ones that have already taken roots? How is the distribution looking like? So we'll see in terms of West Africa, we're looking at Mali, we're looking at Ghana, Benin, Nigeria. We are having some progress that is taking place, that is in West Africa, basically. And when it comes to East Africa, we are not left behind. So we see here decision support systems are doing great. Uganda, we are looking at cloud computing, where it has been adopted, and big data and analytics. In Tanzania, we are seeing decision support systems coming into play, big data and analytics working, and also deep planning also starting to gain, ground there. But we will see that in other areas, like in these sections here, where north, south, northwest, we still don't have. I wouldn't be in a position to say that there is really nothing, but what guides us in the academic world is what has been put out there. One of the encouragements we would do is to encourage African writers to put their work outside there so that the world can be able to see, or even fellow Africans can be able to see the strides that we are making as a continent. South Africa is also doing well in terms of adopting this particular technology. We could not get data when we looked at North Africa, all right? And a lot of it in Central Africa. We were really not getting, and if you look at statistics, actually, Central Africa is doing very, very poorly in terms of food sufficiency. But we also don't find use cases of them trying to adopt or leverage these particular technologies. So as a parting shot, I would say progress is there, but it's slow. A lot of the literature could be at infancy, and in some situations, we could not find literature at all, okay? Now, and it could also be that, yes, there's work, there's research that is being done, but it's not put in the mainstream journals or databases with African authorship. So that we say this has been written by, of course, there's collaboration, but the lead writers are African authors who basically resonate with the African systems and their challenges. Then there is also a gap in terms of methodological approaches and theoretical models or frameworks that can be used to help understand the way these technologies are being adopted and the reasons for resistance. Because if we had these models, then we will be able to pick the right data that would give us, foresight of where we are heading to and why we are not getting to where we are getting. When you look at FOA, they are saying, yes, we are not making strides. We are actually doing very poorly in terms of their report. But again, we want to know, using these theoretical or methodological approaches that are very clear, so that we can be able to see what are the reasons behind these. So in terms, again, of systematic literature reviews to see what has been done. So you see, we were trying to do this within a 10-year period, but we were not getting also too much literature that would give us light into what basically we were looking for, okay? And I think that would bring me to an end to my short presentation, just to give us a glimpse of where we are and where we need to go, and maybe the reasons of why we are not getting to where we want to be. Thank you so much.